Alright, we're on Unit 9 again, Goal 2 this time, talking specifically about parallelograms. So we talked about all polygons on the last unit, and today we're just looking at parallelograms and what are their features that we know. If they're parallelograms, what can we know? And then also it kind of goes backwards too, that if we know these things about quadrilateral, then we can know it's a parallelogram. So we're going to go beyond just the quadrilateral classification and go more specific into parallelograms. So we're going to talk about those properties and apply them, and then talk also about the diagonals of a parallelogram. So parallelogram, you can kind of see a pretty good clue here is parallel. This is going to be a quadrilateral, so we're going to have 4 sides, and opposite sides are parallel. So we kind of have this big quadrilateral grouping, and inside there is our parallelograms. And then we're going to kind of get any further, but here's our quadrilaterals. That's just basically 4 sides, and then interior angles add to be 360, exterior angles add to be 360. And now we're going to talk about parallelograms where opposite sides are parallel, and then we're going to learn some more things. And these characteristics of the quadrilateral are also with the parallelograms, but then more distinct. So here's a bunch of them kind of put together. First, the opposite sides are congruent. So JK is equal to ML and JM take KL. If a quadrilateral is a parallelogram, then opposite sides are congruent. If a quadrilateral is a parallelogram, then opposite angles are congruent. So these angles are congruent. Consecutive angles are supplementary, so they add to be 180. And if it has one right angle, they're all going to be right, because we know these two are going to add to be 180. So if this is 90, this has to be 90. And these two are equal, so those both have to be 90. And these two are equal, so those both have to be 90. So if we have one 90 degrees, they're all 90 degrees. So here we know some things about this parallelogram. So angle B is, and this is kind of our signal that it's parallelogram. So in parallelogram A, B, C, D, suppose angle B is 32. So this angle right here is 32 degrees. And CD is 80 inches. And BC, this side, is 15 inches. So from that, we should be able to find every other thing. This side's going to also be 80 inches. AD is going to be 15 inches. And since this is 32, we can say D is 32 because opposite angles are equal. And then B and C are supplementary. So if I take 180 minus 32, I get 148. So that means C is 148, which also means A is 148 because they're equal, and A and B are supplementary, and A and D are supplementary. So we can find, just from 3 pieces of information, we can find everything about that parallelogram. And I think that's what the next thing says, find C. So we did that by subtracting 180 minus 32. And then find all our other parts. So here, if AB, we want to find AB. So AB is opposite of CD, which is 30. So that means AB is also 30. Find angle C. So if angle A is 36, then angle C is 36. So angle C is 36 degrees. Angle D would be supplementary with A. So I'd go 180 minus 36, 144. So angle D is 144. So the very last thing that we want to talk about before we go backwards is that the diagonals of a parallelogram. So diagonals go from one vertex to the opposite vertex in a parallelogram, and they bisect each other. So they cut, this longer diagonal cuts BD in half, and BD cuts AC in half. And then the last thing too, if I have a quadrilateral, then I have two congruent triangles, which we know so much about congruent triangles because of our lesson on our whole unit on congruent triangles. So we might be pulling some of those things back in where like corresponding angles are congruent, corresponding sides are congruent, and so forth. So have a lot of stuff here, a lot of arrows. We want to find the value of r. So we're looking for r. 4r is opposite of 18, so just have to set up our equation. 4r equals 18 divided by 4, r equals 4.5. So using all of those properties, then we can set up equations and then solve for our variables. Find the value of s. So s is on this diagonal, and what we know about diagonals is that they're bisected by each other. So that means 7s plus 3 equals 8s. And then go ahead and solve for s. S equals 3. Find the value of t then. T is this angle here, and since this triangle here is congruent to this triangle because the diagonals make them into congruent triangles, and also since these are parallel, we can tell that these two angles are going to be equal because they're consecutive interior. So 2t equals 18, so t equals 9. So taking all of those properties, setting up them to make equations. All right, so hopefully you can work some of these examples out. If you get stuck, again, make sure you let me know. Here, angles, or we're talking about diagonals, so we're going to probably use that bisect property. Here for P, we're looking at sides, so we're going to talk about opposite side property. And K is this angle. So it's congruent to 25 because they're alternate interior angles, and also because this triangle here is congruent to this triangle. All right, so now we're going to place this on a coordinate plane and see what we can do to figure out the intersection of the diagonals. So again, remember diagonals bisect each other. So first thing we're going to do is we're going to graph this, and I think I'm going to let put it on here. And then since we know that the diagonals bisect each other, we can actually just find the midpoint of the diagonals. So my diagonals are MP and NR. And remember our midpoint formula is add your x's, divide by 2 because it's halfway, and add your y's and divide by 2 because those are halfway. So I can find the midpoint of MP by taking -3 plus 5, dividing it by 2, and 0 plus 4, and dividing that by 2. So I get 2 over 2, which is 1, and 4 over 2, which is 2. So my midpoint, or my intersection of them, is 1, 2. And it wouldn't matter then if I used an R also. An R midpoint, we'll see it's the same thing. -1 plus 3 divided by 2 for my x's, and 3 plus 1 divide by 2, and you can see we get 1, 2 again. So these should be the same, so the intersection is at 1, 2. All right, that's going to be the end for, let me just make sure of this lesson. So hopefully, if you have any questions, you come in and ask. Hope you have a great day. Bye.